Okay, this might be the most important lesson of the year in Algebra 2. Okay, the lesson is called Solving Quadratic Equations by Factoring. Now, this lesson is going to come into play in almost every unit moving forward in this class, and you're going to need it for your future math classes as well. Okay, so this first thing that you need to know is called the zero product property. It says if the product of two quantities equals zero, then at least one of the quantities must be zero. The only way to multiply to get zero is for one of the factors to be zero. So for example, if I say that a times b equals 0, then either a equals 0 or b equals 0. Okay? So example 1, solve for x. We have x plus 5 times x minus 3 equals 0. So we're going to use the zero product property. Okay? Either the first quantity is 0 or the second one is 0. So either x plus 5 equals 0 or x minus 3 equals 0. Solve each one of those equations. Okay, so the first one, you get x equals negative 5. And the second one, you get x equals 3. Those are my two answers for that one. Okay. Now that one was an easy one because that one was already factored for you. The rest of all the problems, you're going to have to factor yourself. Okay, so whenever you factor, you want to make sure the equation is equal to 0. Okay, so whenever you factor, the equation must be equal to 0, and you always need to check to see if there's a GCF, a greatest common factor. If there is a GCF, you have to factor that out first. So example 2, solve by factoring. Okay, this one's going to have a GCF. The GCF is equal to x, because both terms on the left have a common factor of x. So you factor that out, and it leaves you with x plus 7, because x times x is x squared, and x times 7 is 7x. Now it's just like example 1. You're going to use the zero product property. Either x equals 0 or x plus 7 equals 0. The first one's already solved, x equals 0. The second one, you get x equals negative 7. And maybe you can try 2b on your own. If you pause the video, you can try it. This one's going to have a GCF equal to 3x. So you factor out the 3x, and it leaves you with x minus 4. Because 3x times x is 3x squared, and 3x times negative 4 is negative 12x. Okay? So now you're multiplying to get 0, so one of the factors has to be 0. Either 3 equals 0, or x equals 0, or x minus 4 equals 0. This first one doesn't make any sense, so we're going to ignore that. 3 cannot equal 0. The second one is an answer, x equals 0, or you can get x equals 4 when you solve this one. So those will be the answers there. Moving on to the second page. This page talks about factoring trinomials, 3 terms. Whenever you have to factor a quadratic trinomial, meaning 3 terms, and the biggest exponent, or the degree, is 2, as long as it's 1x squared, like this is 1x squared because there's no number there, it's implied to be a 1. If it's just 1x squared, all you have to do is you have to look for numbers that multiply to the c term, number all by itself, and add to the number before the x. So in this example, you need to find 2 numbers that multiply to 18 and add to 9. And those numbers are 6 and 3. Okay? So example 3a, solve by factoring. Okay, it's already equal to 0. That's good. There's no GCF. Okay. So what you need to do is you need to look for 2 numbers that multiply to 16 and add to 10. Okay? 2 numbers have to multiply to 16 and add to 10. So think about what those 2 numbers are. It's going to be 8 and 2. So when I factor it, I get x plus 8 times x plus 2. Because 8 times 2 is 16, and 8 plus 2 is 10. Now you're going to solve each of these. So x plus 8 equals 0. Solve that in a minute. X plus 2 equals 0, and we'll solve that. So you get x equals negative 8 and x equals negative 2. This next one, you're looking for two numbers that multiply to 18 and add to negative 9. Multiply to 18 and add to negative 9. So those numbers are going to be x minus 6 times x minus 3. Because negative 6 times negative 3 is 18, and negative 6 plus negative 3 is negative 9. Okay? Now solve each one of these. Get x equals 6, and x equals 3. You can go back and test them in the original equation if you want. Okay. This next one, part C. First, you have to get the equation equal to 0, so subtract 27 on each side. It gives you x squared plus 6x minus 27 equals 0. Oh, by the way, let's keep going. Now there's no GCF on the left, so you can look for two numbers that multiply to negative 27 and add to 6. They have to multiply to negative 27 and add to 6. Okay, so those numbers that you want are going to be x plus 9 times x minus 3. Okay, it has to be positive 9 and negative 3. If you switch these and you say positive 3 and negative 9, that is not correct because that adds to negative 6. You have to add to positive 6. Okay? So now solve each of these. Either x plus 9 equals 0 or x minus 3 equals 0. So you get x equals negative 9, and you get x equals 3. Okay? This next one, again, you get it equal to 0 first, so subtract 35 on each side. There is no GCF, so just find two numbers that multiply to negative 35 and add to negative 2. Okay, pause the video if you need to do that, but the pair is going to be x minus 7 times x plus 5. So solve each one. X equals 7. And x equals negative 5. Okay, so everyone on this page, it was 1x squared. See? 1x squared, 1x squared, 1x squared, 1x squared. This next page, that is not the case. So these are the hard ones on page 3. When the coefficient of the square term, meaning this term right here, is not 1, you must factor a different way. Okay, so these are not 1x squared. See, 2x squared, 5x squared, 3x squared, 20x squared. Oh boy. Okay, so you're going to have to factor these a different way. Okay, so first thing you're going to do for this one is you're going to take the number before x squared, in this case it's 2, and you're going to multiply it by that number right there. Again, these have to be equal to 0 first. So I'm going to take that 2, and I'm going to multiply it by that 7. Okay, let me do this. Let me see. I'm going to do this on a separate piece of paper. That way you can see it better. Okay. Just so we have more room, I'm going to do that right here. Okay. I need some room, okay? So 2 times 7 equals 14. That's your first step, okay? Now you need two numbers. That multiply to 14 that you just got. This is going to be called factoring by grouping. We have to add to whatever that number is. In this case, it's 9. So think about the pair. It's going to be 2 and 7. Okay? So what I'm going to do, okay, is I'm going to rewrite my equation like this. I'm going to say 2x squared. This middle term is going to get rewritten as these two numbers with x's after them. So instead of writing plus 9x, I am going to rewrite that like this. I'm going to say plus 2x plus 7x. And then plus 7 still equals 0. Okay, so this plus 9 became these two. Okay, we're going to do a bunch of these, so it's okay if you're having trouble right now. We're going to do 4 of them. Okay, now what you're going to do is you're going to make two groups, and you're going to do factoring by grouping. So I'm going to group, I'll group these together, and I'll group these together. You want to make sure your groups have something in common. So if look at my first group, what do they have in common? What's their GCF? It's 2x. So when I factor out the 2x, it leaves me with x plus 1, because 2x times x is 2x squared, and 2x times 1 is 2x. The second group has a GCF of 7. So I factor that out, and it leaves me with x plus 1, because 7 times x is 7x, and 7 times 1 is 7. At this point, the parentheses should match. See how the parentheses match? X plus 1, x plus 1. So what you do is you factor that out to the front. And everything left over, in this case 2x plus 7, comes in the second set of parentheses. And now you're going to solve each of these. X plus 1 equals 0. Then we got 2x plus 7 equals 0. So x equals negative 1. And x equals, subtract 7, divide by 2. X equals negative 7 halves. Okay. Let's do another one. First, okay, so again, this is not 1x squared. First, see if there's a GCF. There is no GCF for this one. So take that 5 right there and multiply it by that 4 right there. So 5 times 4 equals 20. So you need two numbers. They have to multiply to that 20 right there, and they have to add to that 9 in the middle. Numbers have to multiply to 20, because that's what we got right there, and they have to add to 9, that number. So think about the pair. It's going to be 5 and 4. That's the pair that you want. Okay, so if you remember, you rewrite the middle term with those two numbers. So 5x squared stays. This 9x gets rewritten as 5x, right there, plus 4x. Now you're going to do factoring by grouping, so you're going to make two groups. You want to make sure your groups have something in common, though. So that'll be my first group. and this will be my second group. My first group has a GCF, a greatest common factor of 5x. So it leaves me with x plus 1 in parentheses. Because 5x times x is 5x squared, and 5x times 1 is 5x. The second group has a GCF of of 4. So it leaves me with x plus 1 in parentheses. And now notice how the parentheses match. The x plus 1 matches. So you factor that out front. And then everything else comes in the second set of parentheses. Okay, in this case, what's left over is 5x plus 4. So solve each of these. X plus 1 equals 0, and then 5x plus 4 equals 0. So x equals negative 1. Subtract 4, and then divide by 5 as the lights go out here. Okay. Subtract 4 divided by 5, x equals negative 4/5. Okay, got two more like this. Okay. Factor 3x squared minus 2x minus 8 equals 0. Okay, there's no GCF. Okay, no GCF. So what you're going to do is take that 3, multiply it by the negative 8. That's your first step. 3 times negative 8 equals negative 24. So now you need two numbers. You have to multiply that negative 24 we just got. You have to add to this negative 2 in the middle right there. Think about it. Pause the video if you need to, but it's negative 6 and 4. So what you're going to do is you're going to rewrite the negative 2x for those two numbers. So 3x squared stays. Rewrite negative 2x as negative 6x plus 4x. Minus 8 stays, equals 0 stays. Now do factoring by grouping. Make sure your groups have something in common. So I'm going to group these two together, and I'll group these two together. First group has a GCF of 3x. So it leaves me with x minus 2. Second group has a GCF of 4. So it leaves me with x minus 2. Again, the parentheses match, so you factor that out to the beginning. And then everything left over, in this case 3x plus 4, comes in the second set of parentheses. Solve each of these. X minus 2 equals 0, and then you got 3x plus 4 equals 0. So x equals 2, and x equals negative 4/3. Done. Okay, now this last one has a GCF. So you factor that out now. The GCF equals 5. So 5 gets factored out. You're left with 4x squared plus 16x plus 7 equals 0. Now this 5, you're just going to keep writing the 5 first in every single step throughout the entire problem. But we're just going to factor this like we did A, B, and C on this page. So first you got to do 4 times 7. Okay? So again, we're just going to rewrite this 5 first in every single step. We're going to factor this thing in parentheses. 4 times 7 equals 28. Now you need two numbers. They must multiply to that 28 we just got. And they have to add to the middle term, remember. Not the original middle term. They have to add to that. They have to add to 16. Okay, so the pair you want is going to be 2 and 14. Okay, that's the pair you want, 2 and 14. Okay, so you take that 2 and 14 and you rewrite the 16x with the 2 and the 14, like this. 5 stays, 4x squared stays. Rewrite the 16x with the 2x and the 14x. Okay, now we're going to do factoring by grouping, so I'll group these two together and I'll group these two together. So the 5 is going to stay up front in every single step. This group has a GCF of 2x. Leaves you with 2x plus 1 in parentheses after you factor it out. Second group has a GCF of 7, and it leaves you with 2x plus 1 in parentheses. Again, notice how these parentheses always match. So that gets factored out. You can keep the 5 out front, though. 5 times 2x plus 1 times everything left over, 2x plus 7. Solve this. Either 5 equals 0, or 2x plus 1 equals 0, or 2x plus 7 equals 0. You can ignore 5 equals 0. Solve this. Subtract 1, divide by 2. X equals negative 1/2. Subtract 7, divide by 2. X equals negative 7/2. That page was tough. Let's move on to an easier page to end it, okay? The difference of two squares. Whenever you have two perfect squares, like in this case, a squared and b squared, and they're being subtracted, it factors to become a plus b times a minus b. So for example, x squared minus 9 factors to become x plus 3 times x minus 3. Okay? So example 5a, solved by factoring. So we got two perfect squares because x squared is a perfect square because it equals x times x. Okay? 16 is a perfect square because it equals 4 times 4. So you factor it into x plus 4 times x minus 4. And now solve each one. X equals negative 4. And x equals positive 4. Okay. This next problem is also the difference of two squares because 9x squared is a perfect square. It equals 3x times 3x. And 25 is a perfect square because it equals 5 times 5. So when you factor it, it becomes 3x plus 5 times 3x minus 5. Solve each of these. Either 3x plus 5 equals 0 or 3x minus 5 equals 0. Subtract 5, divide by 3. X equals negative 5/3. Add 5, divide by 3. X equals 5/3. So that was a long lesson, solving by factoring, but it is a very important lesson. We are going to use that a lot throughout the year. So make sure you look back at this video if you need help with it. But hopefully this lesson wasn't too bad.